Hello, good morning everyone. My name is Dhanya. I am your new chemistry teacher. I hope we will proceed these sessions till where we will be able to manage. All the best. Welcome to the sessions. So, our topic is chemical reactions and equations. For studying this lesson, first of all, you should know what is a chemical equation. What is a chemical equation? Chemical equation means, see for example, we will be having a particular reaction, chemical reaction, like a magnesium ribbon burns will produce a white powder of magnesium oxide. This one we can state like magnesium burns to form magnesium oxide. Instead of writing the whole statement, we can write like this way. What magnesium burns means it combines with oxygen to produce magnesium oxide. So, whatever the statement of the reaction we mentioned, that we are writing in this form. That is magnesium plus O2 arrow MgO. So, what is this? This is a chemical equation. So, how can we define a chemical equation? It is the simplest representation of a chemical reaction. Simplest representation. Simplest representation of a chemical reaction. Simplest representation of a chemical reaction. How? In terms of atoms, symbols of atoms, or symbols of molecules, or symbols of compound. Here magnesium is an atom. Then O2 is oxygen molecule. MgO is the compound. So, a chemical equation means it is the simplest representation of a chemical reaction in terms of the symbols of atoms or molecules or compounds present in that particular reaction. So, what do you mean by a chemical equation? It is the simplest representation. Simplest representation in which form? In the form of the simplest representation of a chemical reaction. How? In the form of the symbols of atoms or molecules or compounds which are involved in the chemical reaction. And these chemical equations are of two types. We can classify or we can divide the chemical equation into two. They are skeletal equation. Skeletal equation and balanced equation. Chemical equation and balanced equation. What do you mean by skeletal equation and balanced equation? Skeletal equation means we just represent the chemical reaction in terms of symbols. It is not necessary that the atoms of each and every element is equal both in the reactant side and in the product side. That means it is a simplest representation only. We are not balancing or we are not checking whether the atoms of each and every element is in the balanced state or not. So that kind of reactions are known as, equations are known as chemical equation, skeletal equation. So skeletal equation means it is the unbalanced equation only, unbalanced representation of a chemical reaction only. Only we are considering the symbols of atoms and molecules or compounds which are involved in the chemical reaction. That is known as skeletal equation. The equation in which the atoms or atoms of each and every elements are not equal in the reactant side and in the product side. But if we will consider a balanced equation, what do you mean by balanced equation? Balanced equation means number of atoms of each and every element is equal in the reactant side and in the product side. You know what is the reactant side and a product side. Here you can see this is a representation of a chemical equation, and the substances which are involved in the chemical reaction is known as the reactants, and the new substance which is formed due to the reaction, due to that particular reaction, what is formed, that is known as product. So the substances which are involved in the chemical reactions are known as reactants. The newly formed substance is known as products. And the reactants and the products are separated by an arrow mark. The arrow starts from the reactant side and ends at the product side. This is a chemical equation. And we can check whether it is a skeletal equation or balanced equation. I told you the skeletal equation means the number of atoms in the reactant side and the product side are not equal. Here magnesium is 1. In the product side also magnesium is 1. Reactant side, oxygen, there are 2 oxygen atoms, but in the product side only 1 oxygen atom is present. That means it is not a balanced equation. So we can say this is a skeletal equation only. Now this is a skeletal equation. Then how you can convert the skeletal equation into a balanced equation? We should equate the number of atoms of each and every element involved in the reaction in the reactant side and in the product side should be same. So magnesium we don't want to worry because already magnesium is 1 and 1. But oxygen, here oxygen is 2. So in this side oxygen is 1 only. But you should remember this is the molecular formula of the magnesium oxide. So we cannot change magnesium oxide as MgO2. This is wrong. The molecular formula of magnesium oxide is MgO only. So magnesium oxide, how you are getting that MgO? Because magnesium valency 2 and oxygen valency 2. So simplest representation is the molecular formula. So you have to cross the numbers. Now simplest ratio 2 and 2 become 1 and 1. And that 1 and 1 we are cross over the numbers and you will be getting the molecular formula as magnesium oxide MgO. Now this magnesium oxide formula we are not supposed to change like okay MgO2 because O2 to be balanced. That we cannot do. Because the molecular formula of a compound we are not supposed to change. Then what we can do? We can do the changes only before its symbol. Before the symbol of the compound or before the symbol of the molecule. Here oxygen is 2. So I am putting a 2 over here. As I am putting 2, this 2 is common for both magnesium and oxygen. So magnesium 2, oxygen 2. Now oxygen is balanced but magnesium become unbalanced. So in order to balance magnesium also, we can rub this number 1 and we can write 2 over here. Now we can say this is a balanced chemical equation because there are 2 magnesium, there are 2 magnesium, there are 2 oxygen, here there are 2 oxygen. Most of the students may be having doubts to write the molecular formula, as well as most of the students may be thinking this way, oh magnesium is in the atomic form Mg only, then why oxygen I am writing in O2 form, why I should not write O? Here when you are considering the modern periodic table, there are 118 elements we know. Out of this 118 elements, there are few elements which are present or which can exist only in the molecular form. The remaining all elements are existing in the atomic form. So which are the elements which can exist in the molecular form? Like first we can consider diatomic molecule. Diatomic elements are here hydrogen can always exist as diatomic, oxygen, N2, F2, Cl2, Br2, I2. These are the diatomic species available. Or if you will consider these elements, hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine, these elements can always exist in the form of diatomic state. There are some other elements also existing in the molecular form. They are tetraatomic. Tetraatomic is P4. Phosphorus can exist in tetraatomic form. Then octatomic. That means sulfur. Sulfur is existing SA form. The remaining all elements can exist in the monoatomic form only. Say look here, hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine, phosphorus, sulfur. Here magnesium I didn't put 2 here because magnesium is not coming in this category. That means magnesium can exist as atom only. So I put magnesium as Mg. And oxygen is the second element. So oxygen here you can see it is in the diatomic form. So we are supposed to write only in the O2 form. The remaining all elements except these elements, the remaining all elements can exist in the monoatomic form only. So whenever you are trying to balance a chemical equation or writing the molecular formula of a compound, these things always you should remember. So here another difficulty what the students are facing when they are writing the molecular formula. Here HCl, hydrogen chloride is HCl, whereas magnesium chloride is MgCl2. Why this difference will be? That is based on the valency. In grade 9 you studied about how to write the molecular formula of compounds. I will revise that portions once and you should please, this is my request, all the students should study the periodic table. If you are, okay, for your board examination, the first 20 elements only they will be asking. But if you don't know the periodic table, you are not able to write the molecular formula of certain compounds. But if you know the periodic table, you will be able to write the molecular formula of each and every compounds, the periodic table and certain radicals I will give you. So in periodic table, don't study the periodic table in atomic number wise, please study in group wise. So group 1, actually the position of hydrogen is not in group 1, but even though we are including hydrogen over here for only our sake of representing the elements. Then hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. And here the valency, I am writing valency of this group is +1. Then group 2 elements will be here beryllium, magnesium, calcium, strontium, barium, radium, and its valency will be +2. Then group 3 or group 13, I am writing here boron, aluminium, gallium, indium, thallium, and it will be +3. And group 14 will be carbon, silicon, germanium, tin, lead, it will be ±4. Then group 15 will be